Okay. The wonderful hotel Wi-Fi decided that 24 hours was up since last time I paid for the thing and shut off my connection and said pay for another day. This is at a supposedly very fancy hotel. So, like, I'm offended. I'm deeply offended by this. Okay. What was the last thing I was saying when the F happened? It's not extorting the money, though. It's like, now not only does it cut off my stream, but now I know I can't do a stream that crosses 8 p.m. because I bought this thing at 8 p.m. It'll time out at 8 p.m. tomorrow, so we're going to F again tomorrow. Like, it's so stupid. Did I show you guys the old version of the loop? Right. This is what this loop used to be. And it seriously has ballooned out into this thing with all these if statements that are not very well predictable, probably. Did we get past that part? Okay. So, that's one of the things that I'm unhappy about, is this tight loop getting turned into this very crazy loop, because you can imagine that it runs much more slowly, and we want the back end to be fast. Now, not only is this a big loop, but it's very invasive what it does, all right? So every bytecode instruction has a current statement in it, right? Which is a syntax tree node. And that's annoying because that's an 8-byte pointer, right? And there's one of these on every single bytecode instruction that's output, which, as we established, is like 100,000, right? And so not only does that take RAM, but it's bad for cache. There's 100,000 in the Sokoban game. So that's not great. And what it's doing is actually there might be more. I'm not sure if that 100,000 was after deduplication or whatever, but the point being, there's 100,000 of these on there, right? Let me show you where that gets set, though, because it's even more bananas. In bytecode builder, when we're going to emit a statement, right? So when we're going to output a function, you go to the top level block of the function, right? And you go to each statement in the function and you call emit statement, right? And this goes from the syntax tree. It maps that to bytecode instructions, right? Intermediate representation instructions. It might recursively call emit block. Emit block is just a loop that calls emit statement, right? And then, so we say, okay, whatever. All we really want to do is call emit expression. But again, some fat has accumulated around this because we get the start index. Why? Because down here, after we've emitted expression, we don't know how many instructions this expression is going to turn into. It might be 1. In some rare cases, it might be 0. In a lot of cases, it'll be more than 1, right? And then we have this loop that goes over the loop and just sets the current statement on that, on all those bytecode instructions, right? But like, we're just setting the current statement so that later we can copy it to this other thing, so that even later when we write out the file, we can figure out the deltas of when these changed and put indices in the debug file, right? Like, oh, this statement lasted from, this program counter until this program counter, right? But we actually already know right here, before and after we output the statement, we know how many instructions there were before and how many after. So we could just make a record of like what the instructions were way here in the front end. And we wouldn't have to store a thing on every bytecode, right? And we wouldn't have to have this loop later, right? And then at some point, all we would have to do is map those bytecode instruction indices into program counter indices, which also is a relatively straightforward mapping. The question is just how to do that. Now, that's one thing that we can do to clean this up. Now, there's this other thing, which is all this push pop lexical block stuff where I'm like, what the hell is going on, right? Fortunately, it seems orthogonal in this loop. Like this lexical block stuff looks like it's independent. Like this just adds a thing to an array, and neither of these is being affected by what the lexical block is. So it looks like these are for later, or for later processing. So we could handle this independently, I think. Maybe. We might hit wrinkles. We also need to look at maybe the dwarf encode code to see if there's anything weird. But what is all this lexical block stuff? Well, it's weird because, I was asked at some point to add some support for lexical blocks into the front end so that the back end debugging stuff could use it. So I was like, okay, right? But again, what is debug push lexical block doing? It's taking this struct that was made by the front end, right? And well, it's calling something that we'll look at in a second, helper push lexical block, which probably does some more things. And then it makes a local symbol for the lexical block and adds it to block indices, which is used for address patching in some way, I don't know. And then for everything in the block, we do all this local symbol stuff and then add that to subprogram local symbols. All right. Now, let's look at what this is. We get the address of the thing in this lexical blocks array. This is what the front end made. And then we set the child cursor to 0, so there's like no children, right? And then we say, here's what instruction we're on, right? And that's this function. And I don't even exactly know what's happening here, but like, it's like trying to figure out what instruction it was when this thing was pushed. Like, dude, I don't even know, right? But the point is, all this push pop and whatever the hell that's happening here, like, again, the front end knows what lexical blocks are child of what other lexical blocks. Like, it's not even a question. And probably, and I haven't looked at this very carefully, but probably when we iterate the statements, like we're traversing lexical blocks in order to iterate the statements to generate the bytecode instructions, right? So all this stuff that's happening here in the back ends is just kind of reconstructing stuff that the front end already did and already knows about, and there's no ambiguity. So I think A, it'll be a lot faster just to move all this stuff and where it happens to the front end, and B, I think it'll be less code. And C, I will be happier because there will be less weird stuff. Oh, and the other thing I guess I want to say is, again, I'm not sure about all this because I haven't really looked at it, but like all this stuff about there's this local symbols array and we're adding stuff to the local symbols array. The only reason we're doing that is so that somebody later can iterate over the local symbols array and read the symbols out, right? And write them into the debug file. But like, this information that we're putting in is not going to change. Why doesn't the code that wants to write out local symbols just iterate over block members and do what it wants to with the members? Like, why are we making another intermediate array that's not, it's not going to be nearly as heinous as the giant array um, of the giant array of like every instruction in the program, right? But it's still a lot. Like, how many variables does a 100,000 line program have, including parameters and stuff? It's like a lot. So this is annoying and silly, and I want to get rid of it eventually. I think it's silly, but I don't know because I haven't looked that carefully at it. But it looks to me, this looks to me like data structure theater, where we're just copying something from one data structure into another one, just so that later we can write it out to a file when there's no reason to do that. Now, that said, this may not be quite true. There might be some reasons why it seems like a good idea to do it this way, so we're going to have to investigate. But this is what I'm looking at currently. So, we should be able to get rid of a couple useless loops. We should be able to get rid of some storage on every bytecode instruction, which will make cache effectiveness on the bytecode instructions better. It's really, this is a thing that can get insidious as a program grows. Like, more and more things want to glom onto the data structures, and it makes them less and less efficient, and you just want to deal with that at some point, if you can. Okay, now, this is a little bit challenging because maybe these two things intertwine. And that would make it very hard to, I prefer to just do a small change and verify that it didn't break debugging in any visible way, and then do another small change and so forth. I'm not sure about that. These look independent to me here. And so if we make a different data structure for this, then maybe we can just do a drop-in replacement. If I can get just this part done tonight, I think I'll be happy. Like, get this substituted, that would be good. Because any number of confusing things could happen, things that I'm not aware of, just bugs. Like yesterday, we had a completely unrelated bug that I had done that sort of derailed me for at least 45 minutes or something. That could happen. But so this is what I'm looking at right now. Do I think the original programmer should have commented that intent so I wouldn't need to figure it out from the details? No, I mean, no, not for this specific thing. There's lots of things that I wish people would have commented better, but this isn't one of them because I can at least look at this and understand what it's doing, right? Now, that said, if there's something really non-obvious, like if there's some constraint where things have to match up with each other and it's not documented and it's non-obvious, then that's a place where more comments would be necessary. But I don't like it when there's lots of useless comments because that devalues the useful comments, right? Like this here is a good comment. It's like, look, there's a weird situation where two or more scopes could start or end on the same instruction, so we have to handle that, right? That's a good comment. This is the code that pushes and pops lexical blocks would not be a good comment because that's obvious from looking at it, right? It seems like the person who wrote this didn't know what the front end did. But I talked about this yesterday. This happens with all software. People can do a better or worse job in various instances, but you have imperfect information sharing and people don't know what's the best way to do things, right? And people have different experience level. People have different skill sets in terms of knowing what's fast and not knowing what's fast and so forth. So just this happens. I have never seen a software development project where things like this didn't happen. That wasn't trivial. Ever, right? Now, maybe you can make them happen less, but this is just a thing. Don't forget to track any speed improvements. Oh, that's the other thing to say is I do think we would get a speed improvement out of all this. I'm not sure that it would be super measurable on this noisy laptop, right? If I had a very stable performance-wise stable laptop, it would be easy to measure performance improvements, but we just get so much variability, you know. Like here we got 283, here we got 343. That's a 20% difference, right? 353. Like it's all over the place. So this laptop sucks. Intel Inside. And this is a little bit weird too, because I think we would be taking, I'm not sure if it would be net faster everywhere or if we would be adding a small amount of front end time in order to buy a larger amount of x64 time, right? I'm actually not quite sure how it's going to work out. We will see. How fast is the compiler compiling the entire game? We just did it. That's what... Did you see what I just did? I would compile the game 3 or 4 times right there. Chat is funny. What is current lexical block used for? Well, I don't exactly know, right? I believe it's used, like I remember seeing something yesterday in Dwarf about lexical blocks, right? So I believe the debugging info may want these things. We're going to take a look. I think it's, if I were to guess, it's so that you know which symbols are in what scope, right? Because, you know, if you have a local variable and it's got some allocation on the stack, that doesn't mean that the function pushes and pops the stack when it becomes live, right? Because that's inefficient. So you kind of want to know the range of instructions for which that variable is live, so the compiler knows that it's no longer relevant when you exit that range. So that would be my guess at what it's for. There may be better ways to do that. Is the pointer to the ast in the bytecode instruction just for the debugging info? I believe so. Let's actually, that's a good question. It's something we should verify. So this is code that sets it, and this is code that uses it. And it is literally only used in 2 loops that do the same thing about, I mean, for LLV, this is the LLVM backend, and it's doing set current debug location, like okay. And then, you know, down here is the loop we were just looking at. So what I would like to do is the following. So all we need to do is somehow tell the backends, oh, this statement corresponds to this range of program counters, or for the LLVM backend, this range of bytecode instructions. And we can do that just by saying, here's a statement, here's an array of statements, right? Debug statements, and it's got a node. Again, we'll keep this 8-byte pointer, and then we'll have like 2, you know, U32s. So you better not have more than 4 million instructions in your function, I guess, for now, or you won't be able to debug it. But it'll just be the starting index and the ending index for that statement, right? And then our first iteration of a loop would still do some slow stuff like this, but then you can imagine once you get the push pop stuff out of the loop that you have a very tight loop where you say, okay, what's the next index? We start the next statement. We say, okay, iterate from, you know, from instruction A to instruction B, blam, tight loop, and then copy the, either in LLVM, set the debug location again, or in x64, you know, just copy out the the instruction locations. 2 seconds is pretty insane. It is much faster on a desktop machine. It's like less than 1 second. Dwarf stores live ranges for every variable. Yeah. What exactly is a statement in this context? Well, I mean, it's so in debuggers, there's a command go to next statement, right? So it means however far you want the debugger to go when somebody says go to next statement, which in a language like this is usually, you know, it's usually pretty clear. It's not that different from C++ what a statement is. But it is a little bit arbitrary in some sense, right? Like we could decide to do weird things with that. Anyway, so that's going to be my job tonight. And I do have to say, I was in a really good mood today, and I just got in a worse mood when I started the stream. So I'm going to take it a little slow. Let's do a little bit more. Any other questions about this code before I dive in and start messing with it? Is there anything in the language that's hard for debuggers to understand currently? I'm not sure because I haven't done a very extensive job of thinking about it. Like we definitely have, you know, we have hygienic macros where, you know, like you're sort of in 2 places in the code at the same time. Like when you're executing the macro, you're kind of in the part of the file where the macro is, but you're also in the calling function, right? And what that means for various purposes of debugging, we haven't just done a job of thinking about that. So like, can you set a breakpoint inside the macro? Probably, I guess. You don't really want the macro to be on the call stack though. Or if it is, you want it to be, I don't know. It looked like Dwarf had some macro stuff that we might be able to use, but honestly, I just haven't looked at it. That would be my first idea though, is hygienic macros. Other stuff, like all the code generation options and stuff, we actually output generated code to a debuggable file, and then to the debugger, it just looks like any input file. So, yeah. Rust macros with regard to debugging is a mess right now. Oh, that's a bummer. Is a macro a procedure that triggers different functions? A macro is something that you call like a procedure, but it's not actually a procedure. It's more like a symbolic manipulation of the arguments that you passed. Right? That's a general enough statement about macros. It might make more sense to make it look like an inline function. Yeah, maybe. Like I literally haven't thought about that at all. These past few days of looking at this code view in Dwarf code is like the first time I've done that seriously, right? So it's all new to me still. Dwarf macros are extremely C preprocessor centric. This is what's so weird about Dwarf to me, right? Like, on the one hand, it's got all this crazy, you know, programming language, virtual machine stuff, which you would think would mean it's geared up to handle all kinds of weird programming languages. And then it just gets used for C++ stuff. which like isn't that hard. And code view can do just fine, and code view is way simpler. So what is all this dwarf garbage in the end, right? Like, what does it buy you? Really? Most of it is just letting you debug optimized code, but you could do that in code view too. I mean, to some degree. I guess I haven't done a quality comparison of dwarf v code view. Oh, so, you know, I ended up reading last night after the stream, I ended up reading this section 6.2 about this stuff. So you basically meant using these special opcodes, right? Where, you know, if you happen to have, basically if you happen to have a line count delta and a program counter delta that both fit into a predefined range, then there's an opcode for that, right? And then you don't. I forget where they're listed, but there's just some table of all the opcodes. Oh, there it is. So like opcode 13 to 255 are all hard-coded skips, and so if you have something that's in this matrix, you just output that byte, right? You also save space if only one fits and use +0 in the special opcode and the longer form of the other. Okay, I haven't actually looked at, I don't understand that part yet, but yeah. Why use dwarf? Because I want people on Linux to be able to debug their programs that they compile. Uh-oh. Hang on 1 second. You're wondering if it's possible to have a constant be part of a struct. Yeah, that's just fine. It doesn't affect initialization at all because constants don't have any storage. That's exactly the same as what C++ calls a static class member. It's the same thing. I think the general idea is having a super smart compiler outputting a crazy debug info that we then pass into a dumb debugger that's controlled by the compiler via the crazy debug info. Yeah, but like nobody does anything interesting with it that I've seen. Like literally none of this machinery gets used. It's crazy how much complication it is. You're guessing interfacing with dwarf is easier than starting from scratch and having Linux people adopt it? That just doesn't make any sense. Like, I don't want to also make a debugger. That's just too many things. And then force people to use that debugger that they don't want to use. It's like too many things. Like, that would be a thing Fixing that problem would be later when we make an operating system, right? That's the right place to fix it. Because then you have your own executable format. You can make your own standard debug format for that executable format that is not crazy. Okay. So I could actually derail and just go do this right now too. That would be fun. Kinda, but not really. It's really funny how, like, they didn't even make it all the way to the end of this line. So you can't even check both ranges maybe because if it's 20 bytes ahead, it has to be a jump backwards or else you can't do it. Like, what? Like, I'm pretty sure almost nobody ever uses this line, right? I would just do like 0 to 19 and minus 3 to 8. Do you have to have your own executable format to make your own debugger with its own debug format? Couldn't you embed it in the executable? I mean, I don't know. Like, I suspect I would just want to do it from scratch, everything. I don't know, though. Because, like, the executable format is related to the debugging format in some ways. Like the way symbol patches work and stuff. Table is, oh, you specify the ranges in the header. I guess I didn't read that part. Oh, I see. These are the values of these variables. Opcode base, line base, line range. Wait, why 13? My eyes glazed over when I saw this. I was just like, whatever, guys. Could you load the browser at compile time, get the PDF, and parse the table automatically? I wouldn't do that by loading the browser. I would do that with wget, but you could. I don't know why you would. That's a terrible idea. 13 means, oh, I see. 13 is, all right. Okay. Anyway, that's going to be for another time because I would rather work on the structural issues here. Although, honestly, I just don't want to work tonight anymore. But we're going to do it. We're going to do it. So, well, you know, my idea of how to approach this is just start doing the new thing. Okay, so we want to see where subprogram lines is being used and then make a thing. We can still keep this here for a while, right? So that other backends won't break until everything is together and works. So let's look at not very much, thankfully. So this is the thing that I guess outputs file names for every statement in the subprogram, I guess. And this is mostly just an array of offset and line number, right? Where the line number is stored in the syntax node, yep. So that's mostly straightforward. And then this thing about the file name changing, you know, that's actually also pretty straightforward. So I'm not really scared about that at all. That's what we were just looking at. This is a weird thing where we add a statement just to put a dwarf prolog end in there, which is obviously just for dwarf. So like, but I think this is always the first subprogram line. Yeah, because we just allocated the subprogram. So we literally just always say prolog end is the first thing, aka we don't frickin' have a prolog. So we could just put that knowledge into the back end, right? So when we go, I think I want to do code view first, but when we go replace dwarf, I think we just do that. Like we output the, like whatever process one line does, right? It had, I guess we can go, okay, so this is the only use of subprogram lines, right? Process one line says, you know, where if it's got this flag, do this. But we can just output that byte. We could actually set a breakpoint there and make sure that it's the first one every time. And then instead of doing that, we can just output that byte up here and just say, look, there's never a prolog. All right, deal with it. Or actually, I mean, there is, well, okay. It's a little weird because there is a machine language prolog, but it doesn't have any bytecode instruction or like expression correspondence. So this wouldn't do anything relative to that anyway. Anyway, so this actually all seems pretty straightforward to untangle this part of it. So I'm just maybe going to start doing it. You might want to read the version 3 doc. It doesn't have VLIW support. And the simpler formulas work just as well in version 4 if you don't use VLIW features. Just keep in mind the header is different. Yeah, I don't use VLIW features. But, I mean, maybe we will eventually. Like, are you including just general modern SIMD intrinsics? Or do you mean like literally targeting VLIW processors? Anyway, so there's just a feature for one instruction address to contain multiple instructions. that you don't care about in x86, 64. Okay. Okay. So the trick would be to downgrade to Dwarf version 3. Okay, so what I want to do is make my new version of this information. And that is going to, like I said, it's going to have the current statement pointer in that thing, but then there will only be one of these per statement instead of one per instruction, so hopefully it's substantially fewer. And then it'll have the number of the beginning and ending bytecode instruction. And then in this place, we will add to it the beginning and ending of the machine code addresses, which is going to be weird because I feel like that'll work better dovetailed with the new version of the lexical block thing, but I don't want to have to do them both at once, right? It's weird. So way back when I do asked lambda, way up here, I want to make a new struct called struct debug statement, statement debug info, right? And this is going to be statement U32 first instruction. This is a weird thing where like I don't want to subtract 1 because we're using unsigns, right? Last instruction index plus 1, right? Because like we just want to take the array index when we're done outputting the instructions and say, oh, it's that index. So that you would say, I is less than in your classic C for loop, right? But you don't want to subtract 1 because what if it was 0 for both of these? Then you're bad news bears, right? So we're just going to do that. And for now, we're going to have this be an array on lambda body, I guess. This, maybe we shouldn't make this an array because again, we're going to pay costs for copying this and stuff. But you know what? At some point later, we could add a bucket array to the compiler or maybe even make this a linked list, although I think bucket array is probably better. And then, that'll be a very small change, right? But in the meantime, I think we just do this. Okay. So then, in bytecode builder, where we say emit statement, hopefully we have the lambda. Let's see. No, we don't have a back pointer to that, which is fine. Hopefully we have a current lambda. Yes, okay. So, we're going to say We're going to make this look bigger and more complicated, but then we're going to cut this part out later, so it's going to be fine. We're going to say right, do we set a body pointer? It's like I've changed some of these things enough times. Yeah, okay. Oh, I'm saying remove me, but I don't think we want to remove it. We'll find out. We'll find out if this is all actually true. So when we emit a statement, we're just going to say info is lambda, we'll say auto body. We're going to the auto body shop. Info is body statement debug info add, right? And then info current statement is expert info okay. This is the crappy part. Because this is in a resizable array, we need to write the starting index here and then the ending index here. And in the meantime, we might emit a lot more statements and it could move, right? If this were a bucket array, it wouldn't be a problem. But we're going to have to do something annoying, and I will comment it that it is annoying. So info first instruction is start index, right? Just, no, because we're probably not going to keep that. Byte code instructions.count. And then down here we're going to say info equals comment this in a second, right? And then, whoops, last instruction index plus 1 equals, and then the same thing. Now that said, we could retroactively decide to erase this. I guess not. There's no point. Like if it's a 0 instruction width. And that is just this. All right. Okay. So we're going to say all right, so the reason we're doing this is because down here we're going to have to say the array could resize while we are in emit expression, thus invalidating our pointer. If we make it a bucket array, we eliminate this problems, and it's faster anyway, so we should probably do that. This is one of those bugs where if you don't think about that and you do it, you pay if you're a noob. Anyway, let's just see if those asserts go off, or let's see if we even compile, because we probably don't. What's the annoying stashed index? That's just a tag. Anytime I put a comment with a colon like that, it means there's a tag that refers to something else in the program, right? It's a way. So one of the problems that you have in code is that, you know, sometimes there are things that are the way they are because of something else somewhere else in the program, right? And you want an easy way to indicate that. Sometimes those things are very far away in other files, right? Wait, there's already a statement debug info. Did we actually use that? Like what? feel like someone does use that. Dang it, dude. Oh, wait, no. Statement. Yeah, it's not current statement, it's just statement. First instruction. Why is it complaining about, oh, instruction? Someday we're going to, you know, if I get in a bad enough mood, we're just going to remove warnings. Do I have to Control X A a lot? I don't know what Control X A is supposed to do. What is Control X A? That is an incomplete command in my Emacs bindings. All right, so that compiles. Oh, Control X a lot. No, I don't use Control X that much. Sometimes. But like most of my bindings that I use are not Control X whatever. Okay. We built the whole game without asserting. Let's do the tests just to be... I mean, it looks fine. So this is great. So we now have this information. So how would I, if I don't want to look at subprogram lines, or no, don't want to. All right. So I think the next step is fill out. We're going to add more fields to this statement. So instead of having subprogram lines be a separate thing that gets added, we're just going to have 2 more lines in this debug statement. Oh, you know what we forgot? To only do this if we're debugging. Right. So, and this is something we can optimize later as well. Like this didn't seem to care, like whatever. That's an annoying thing is we're paying this size on the bytecode instruction and taking the corresponding performance hit right now, whether or not debugging info is enabled, right? Whereas now, after we do this change, also we will only use it if debug info is enabled. All right, so actually I have to preserve the old semantics, I guess we'll do this, right? And then we have to put this down here. All right. It's a little too much code, but it'll slim down. Whoops. Dang it, bro. It'll slim down. Whoops. You're writing Dwarf, which is for Linux, and compiling on Windows. Aren't the debug info generated depending on OS and different for each OS? Yes, but you don't want to, like, it's very silly, the idea that you can only make a Linux binary if you're running on Linux, and you can only make a Windows binary if you're running on Windows. They're just file formats. Executables are just files in a known format with bytes in them, right? Now, historically, though, we've ended up in this screwed up place where everybody relies on all these system headers to like try to build things. And those system headers are only available on the target system. And so like you can't cross compile all of a sudden, but that's stupid. That's this new idiocracy version of computers, which isn't what it used to be, right? So like, don't use system headers and you don't have that problem. You know what I'm saying? A dwarf file is mathematically defined. It has a right answer regardless of what operating system you are running on. Does that make sense? You make Windows executables on Linux all the time. Well, that's because somebody went through the work of making that happen, I guess. Is that actually a thing? Can Clang do that? My mints container is stuck closed. Yeah, the whole point of cross-compile languages was to cross-compile, yes. And like that's kind of been lost. Oh, using the min.gw packages. But that's not even like, no, you should just be able to, you shouldn't have to do anything special to compile for another target. I can't get my mints open. Great. Okay, anyway. So we've got this statement debug info now. It is being added probably in the appropriate place. Eventually this is going to be removed, right? This thing and this thing. And we'll probably slim some of this stuff up. Yeah, we'll see. Anyway, next. Did I make sure that we compile again since that changed? Debug build. So now let's add some fields to it, right? We'll add two more. U32 first. Program counter. U32 last program counter. See, I want to use it. After last program counter, right? Because this is sort of like where the next byte of the following instruction would be. Okay, so we somehow now have to make those in this loop in x64 converter, right? So now this is maybe a little bit tricky because we have some array of statements, and oh, you know, this one doesn't even have a last. It's just got where each line starts, which I guess makes sense. Let's not even record the last one for now. All right, let's call it offset in text section, right? Because that's the same name. So many files. Offset in text section. If we don't, maybe we don't even need this last instruction index. You know what, for now, let's get rid of that. Because then we don't even need this whole ting-tangler, which is great. If we need to bring that back, we could bring it back. That might come back, especially with lexical blocks. I don't know. I don't know what that's going to look like. Clang supports outputting any format on any OS. The problem, as you might guess, is that you need toolchain header crap. Well, that's exactly what I don't want. Right? I also want to get my mince open. Ah. Okay. Next. Wait. Debug again. So, we need to set this, and we're going to assert some things. Again, we're going to make this loop a little bit bigger than we wish it were. I'm going to get rid of this other buffer so I have an easier time switching around. Because now we're not only going to be doing this, but then also the other thing, right? Like, this lexical block stuff is weird. The reason why this is so complicated might have to do with the fact that this isn't storing both ranges. I don't even know. We're going to look at that separately. So here we say if current statement debug info, right? Because we're going to cursor this forward. If I is equal to current statement debug info arrow, whatever that was called, right? First instruction. Then, now again, this is something we can change into a tighter loop later. Right now we're going to leave it as a loop with an if statement, but later this could be unrolled, I think. So if I is equal to current statement debug info first instruction, then we set that. Whoops, I spelled it wrong, so we have to kick off a compile of everything again. Offset in text section is output.length, and then is greater than or equal to this might even be unnecessary to do this check. Okay, well, what is current statement debug index? That's 0, and auto constant statement debug infos is lambda body. All right. So, and then statement debug info arrow current statement debug info is null if statement debug infos of 0. Okay, so this looks like a lot of code, but it's better than the old thing, and we will be able to deal with it better. Arrow. Wait. Oh, so it doesn't like the const. Dude, I don't... Every time I try to do const, I just regret it. So, screw you. Why doesn't the error message just say, we didn't like the const? Like, why do... Come on, guys. That's a problem often enough that it's worth doing. Okay. Well... In theory, we now have the information that we want here instead of here. I probably screwed it up. Who knows? And actually, you know what? Instead of keeping a pointer to the debug info, let's do it even a little different. All right. So what we're going to do is say current statement debug info is not even a thing. Dot first instruction. Okay. So if we're equal, current statement debug instruction. Okay. And then down here, this is a little bit bad because it'll crash if you have 4 gigs. Actually, no. No, it won't crash. Never mind. So there we're not even dereferencing a pointer. That's good. Actually, it will crash if debugging is disabled and you have 4 million. I don't know. Don't worry about it later. Okay, so we do that, and then we say so the reason this works is, wait, I know I spelled something wrong here. I thought I did. Oh, statement, yeah. If we hit the end of the array, we just leave the index as I, and once we have passed it, we will never ever hit it again. Okay. Oh, this is statement debug infos. Okay. So I like that a little better. It's still, it probably is wrong, but whatever. Great. Maybe it works. We could step through that at some point if we want. The reason I like this better is it'll be faster in the interim time before we, do some unroll of this, which might be a while. I don't know. Like my goal right now is just to get the data better, and we don't want to do the unroll till we can get rid of this stuff too. So now one other thing we could do, okay, that may be better than this, and it depends on how we end up doing the lexical block stuff. But if, like, one thing I could do is just have a local array where I store the program counter for every bytecode instruction, right? And we can reuse it. Like, it doesn't have to be stuff that we allocate. So we just blast through and store the indices, and then we just iterate over all the blocks and all the statements and just like dereference that. You know what I mean? It's just, again, I can't do that without modifying this, which is territory I don't want to get into yet. But that's probably better. And then this code, like all this stuff, wouldn't even really, it would be much simpler. It would just be copy, 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 which is the kind of code that tends to be fast. Const is typically easier to use in code bases where it's used everywhere rather than in isolation. Yeah, that's the excuse that people give, and it's never true. The only reason it seems that way is you're used to paying all the terrible costs of working in that code base in the first place. Like, you're already used to everything sucking, so it doesn't change the level of suck. Okay. Well, I guess the next step is to try to use this and then see how bad I broke it. So instead of subprogram arrow lines in code view, we can use this. Let's see. So this is where it gets a little bit gnarly, but this should be able to be a one-to-one mapping. I don't know. Actually, before we do this, let's compile the game and then just verify that we can debug the game normally, right? Which we should be able to. I didn't change anything that should break that. But again, it's a higher likelihood that we will break that when we do this next changeover. And knowing that the base case is fine, whoops, is valuable. So I'm just going to F5. Your keyboard is going crazy and skipping characters sometime. If only your keyboard had been programmed in Rust, that wouldn't happen. All right, great. So I'm actually going to commit this. No one will ever tell you I'm afraid of commitment. I hope I don't have a no check-in. Let's see. Nope. All right. Okay, so work toward the new debug info thing. Great. So now I'm just going to no check in this, and I'm just going to copy the whole thing. And we're not even going to do this right now. We'll leave those there. Why not? Why not? It's just I kind of want to handle that differently at some point. Okay, wait. Oh no, we have a comment in there. C style comments are the worst. They're the worst. They're the worst. Why is this? Really? Seemed too indented for some reason, but I guess it's fine. Okay, so instead of subprogram arrow lines, we want arrow body, arrow statement debug info. Okay. So this is all file name stuff that's the same. I don't exactly like this, but this is fine. Like, I guess that's okay. I probably missed something. Like, this is literally basically exactly the same. Ah, yes. Lambda. Oh. Okay, well, let's see what happens. Let's see if it explodes. I mean, I didn't do anything to validate that that's actually working. So the probability is high that it doesn't work. It doesn't work. And the reason why is because our breakpoint didn't happen and it's got a question mark. So that's fine. We sort of expected it not to work. So now the question is why? And we're just going to like look at what it's doing here, right? I probably messed up something really simple. Nothing that we did was really nothing that we did was rocket science, right? So line 2979 is around here, and then we're just gonna like break here and see what happens. See if we have other break. Nope. No other breakpoints slowing us down, hopefully. Okay. So current statement debug instruction okay, so we won't do anything. I actually wonder what this is. Init stack trace node. Oh, so we do have a preamble. That's right. We'll think about that later when we do dwarf. Actually, the preamble is our first state, ends right when our first statement's instruction begins, so that's fine. All right, so now, current statement debug instruction 1. Boom. Offset in text section. Boom. Current statement debug instruction becomes, whoa, that's not right. Excuse me. Does it have all ones in it in the array? 6. First instruction. First instruction. First instruction. First instruction 2. First instruction 5. Okay, wait, what? What are these statements? Declaration? So, static if. Bro. We don't need to output that. That's fine. Declaration, that's fine. Probably constant declaration. And then an if. Oh, I can barely see it over. See, if we weren't outputting all these garbage numbers, I would be able to see more. Like see more of the sea monster. If return procedure call. Okay, I mean, this doesn't look the worst, honestly. Except that we don't initialize offset in text section for these guys, and that might be let's do this. Instead of if, we'll do while. Again, this won't be an issue later. It's possible. It's possible we should try to remove those, but that's annoying to do. So we won't. All right. I is 1. Okay. Now the flaw is this will infinite loop. So we actually need to do this. Oh, God, fuck you. Let me type what I want to type. Else this equals all right. You know what I should do to make this more readable? Okay. 1. Oh, that was just the termination of the while loop. So now we're at 2. This is a different function than last time. Declaration, binary operation. Anyway. Like, it looks like it's kind of working. See, that there's a procedure call that generated a lot of instructions, right? Oh, geez, the next one is even more. And then a few more. And then a few more. And then we're done. So all of statement debug infos should have initialized offsets into text section. Yeah. So I mean, that looks to me like it's doing the right thing by Spike Lee. I still suspect it doesn't work, but we'll see. Maybe. Maybe. Oh, it doesn't have a question mark. Who knows? I don't know when it puts up the question mark. Loading. And spilling water. Hey, look. We're in the right place. Look, we could step into POW, except we don't have the source to POW, probably. So let's go here. We have random get within range. Although, why are we not showing that file? Did I confuse remedy by stepping into libc? Let's do this again. Maybe we messed up the file names somehow, but like it appears from first first look that we can actually so rotate 45. So step into like doesn't seem to work, which is weird. Oh, but that's what it would be. No. Why would what we're doing break step into? But if I go to like, I bet if I go to random get within range, for example, I bet I could actually set a breakpoint here and then go, and then we're here. So this is weird. Literally, it's just step into, which doesn't work. Now. Why would that be? What were we outputting before? I mean, I don't think the old code was like doing anything. I seem to remember testing step into before. What I could do is uncomment that other loop because the other data is still there, right? We haven't removed the old data. So we could see if that fixes that. I mean, did I actually test this in the pre-test? I don't know. I need more chocolate, man. I don't have any. I don't have any. Yeah, that's my best idea is to do the old version of step into. Quick feed chocolate. There's a chocolate and tea place that I can go to tomorrow. I couldn't go today because it's closed on Sundays. So, okay, let's see. Back there. So I know there's comments around this, so I'm just going to go if def blah blah and if. All right. So now we're going to use the old data and we're going to see. Oh, there is that whole thing where we were adding the statement that has like end preamble, and we of course don't check for that flag end preamble, so I didn't worry about doing anything like that on code view, but there might be some other effect of adding that. Like it might trigger the thing in some way. Anyway, let's so we just compiled. And I'm going to go here. If it's broken, then I don't know what I'm going to do. Is there an issue with the first line of a procedure? I mean, we do sort of have a range. It's true. Okay, right. At the beginning of a procedure, hold on. We're breaking too early now. It is true. At the beginning of a procedure, we have some code that is not assigned to any of these ranges, which probably it doesn't like, right? So what we could do is add one that's just the preamble, right? That would make sense. We would have to save that data somewhere. Actually, we have that data. Okay, so here I'm just going to go to random get within range and then step in. Yeah, so that works. So probably it's this one. I keep trying to find the right place. So this subprogram, I believe, has I think, does Lambda have, I think Lambda has okay, so it has offset within text section on it, right? So we could output a thing like that's the first one instead of or since we know we're always going to want this, we can just put one in the array, like that we skip over. Yeah, let's do that. So here in bytecode builder, when we go emit lambda, here we go. So build, right? Very intuitive. This is where all lambdas go to be have their bytecode generated. And what I can do here is, before we do any of this, we'll go, do we have body? Yeah. We go to the auto body shop again. Do we have one later? No, interesting. So we just check this has a body flag up here, so we know. Of course, those two pieces of data could be out of sync, but that would be a compiler bug. So now we're going to add a thing. Oh, you know what? Over here, we don't need info to escape anymore because we're not even doing that. So, I mean, we might later, but let's do that. Okay. Over here, we're just going to say statement is null. We could say statement equals lambda. So we're just going to do that. All right. So there's always at least one. We can skip that here. Actually, yeah. This is the preamble statement used to catch any code prior to our first output bytecode instruction. I guess. That's how we're doing it right now. Okay, so it's very similar to what the other code was doing for the other thing. We're just doing it in a different place. So then, what about our file name loop here? So we get our file name off the lambda. If this is the first statement debug info, it is the preamble info, and we get our file name from the lambda itself. In most cases, this file name will not change for the entire loop. Okay. So we do that. The thing is, for the 0th loop, we need to set the offset in text section for it, which we weren't doing. Dot okay. It's a little squirrely. Who knows what a bad job I did there. Let's see if we can do things. How's it going in chat? Auto is just a laziness thing, kind of. But it also makes code more readable sometimes. Like if you know what the thing is, why say it? Like I know what lambda body is. There is no confusion for me about what... Okay, it still doesn't work. Dang it, bro. And we never recover, interestingly. Well, let's look at that loop. The file name loop here. Okay. Hey, it has an idea for me. What's your idea? Add macro 4 to new C++ hint. What? What does that even mean? Why is that a hint for me? Okay, I'm a little bit scared. Okay, never mind. That might have just been me clicking there. Okay. So surely we have a valid file name index. So this is if we changed files, right? Otherwise, we're setting the file. Wait. I did the wrong thing. I put in the offset after the preamble's been generated, I guess. Wait, what? What? I bet it's the same for the first two now. So the first one is 58 bytes into the text section. The second one, 138. But the lambda's offset. Wait, what? Like we actually, I think, just want to use this. So why did I goof on that? Why did I goof on that? Wait, is that even set at that time? I guess so. Hold on. So that's for the whole thing. Oh, I didn't realize the tight loop was down here. This is if debug info is off, we just do this, which is what we want to do as close to that as possible, right? Okay. Oh, emit stack backing. Yeah, I didn't realize that was way up there. Okay. So now maybe it's better. Maybe. Maybe. I'm getting hungry, guys. I might stop the stream, go to a hotel restaurant, get a little food, and then start a second stream where we attack Dwarf, if this works. I'm not that hungry, but... Alright, so, stepping in. Yay, everybody. Random get. Yay. Okay, this is good. This is good. So what this means is for code view, we can get rid of that CTX arrow lines array, which means we can get rid of debug statement on the bytecode builder for code view. However, not for Dwarf and not for LLVM, but hopefully both of those will be easy. Like, I think we do Dwarf first since it's probably not that different from what we were just doing. And then we could do LLVM as well. So what I want to do is I want to delete this situation. And then I want to make a build, and we'll just verify that it passes the test, because it might not. What food will I get? I don't know. Got to fuel those gains. Yeah. Any questions about what just happened? Why are there so many things running? That's my question. Why can't we have these use just a little bit less vertical space? Very successful. Like, it is 10 p.m. though. It's a little late to eat. But I also don't want to starve. So yeah. But I'm also getting fat from not exercising. I don't know what to do. This life presents so many choices. Can't use smaller icon on the taskbar. Not last time I checked. Why did it like magnify this up so big anyway? Taskbar settings. Oh, no, those are really small. I mean, I guess, but like, I want less vertical space. Where's the option to not be an idiot about vertical space, right? I don't have that option. I want this size, just like get rid of half the vertical space and I'm good. I mean, I guess I'll try this. I just don't like it. It's too small. And like, look how huge these are. Like, what the fuck, guys? Windows doesn't have the option to not be an idiot. That's true. Unfortunately, neither does Linux. So the problem about diet is, right, if I'm not exercising vigorously, then it's true that like right now I am not, what would I call it? Like there's a certain kind of like direct hunger where it's like your stomach's grumbling, you very much physically, like your body really wants food so it doesn't start, doing bad things, right? That is not where I'm at right now, but the problem is, if I don't eat, my body temperature will drop and my brain will slow down because my body's trying to conserve energy, right? So it's a little screwed up. And so it's this thing where it's like, well, I better eat if I want to keep programming well. So yeah, I think I'm going to check this in, another partial check-in, and then I'm going to go get some food, and then my goal is to try to push this change all the way through the compiler tonight. So I want to come back and do dwarf, which hopefully most of the work for that is done. We could even remove the prologue flag because we know the prologue is the first one. And then do LLVM, which hopefully also is easy. Like LLVM is just not efficient at all anyway, so there's almost no point in trying too hard to optimize it, so we just have to make it work. Am I diabetic? No. All right, everybody, we'll be back in maybe an hour or something. I mean, maybe the restaurant's closed. I thought they were saying it was open till 11, but that might have just been yesterday. We'll find out. Maybe I'll come back in 10 minutes and be grumpy because I can't get food. All right, thanks everyone. Back in a bit. How do I stop? I don't recognize the icons because they're so small.